can be done at different levels of abstractions. You can do them at the unit level. The smallest possible unit in your program, you can test it, which typically it is a function or a method call. You test it. Then you put this piece to make sure, the purpose there is to make sure that the pieces are working. Then you move and you put those pieces together into a much higher level component, and then you test that those small pieces are working together. And we call this integration testing. And then the whole application, you test it to make sure it meets the use cases or the functionality the user expects, and the non-functional aspect in terms of performance, in terms of security, in terms of availability, and so on. By the way, just from experience, you know, users are very nice. They can give you coffee and biscuits when you are developing, but you will see a different face when it comes to testing. Okay, they will not accept what you give them easily. So this is the hardest part. It's called acceptance testing, because that's where they will show you the real face. They will be very harsh on you. So you need to be ready for that. And basically, they will give you feedback. So the tip here is you involve them in the whole journey. You don't just go in your corner, start developing, and then you surprise them. Here is the system. You will be surprised. They will not like it. They might say, oh, this is not what I expected. So it is very important to test early and to get the users involved. When you have some early prototype, go and give it to them, discuss with them, and so on. So similar to what we have done in the project. Before you dived into the actual implementation, you did some early prototype. Just how the user interface looks like, what's the navigation experience, the user experience, and you show that to the users. You can even give them to play with it. You tell them, of course, this is not fully working, but I just want your feedback. So you don't run into surprises. And these surprises are very, very hard to fix. They're much easier to fix early than later, okay? So, and I have seen this in real life. You would be very, very surprised. Acceptance testing is very hard. So the more you involve them, the better. In fact, I've seen strikes where employees, they just leave the organization. They say, we will not use this system. It is just so hard to use, or it does not meet our requirements, or whatever. So you need to be very careful. Okay, so you can think of it as, here we are basically testing the units. Here we are testing the units. In here, I'm testing the functional testing when the units are put together, and in here I'm testing the actual workflow to achieve certain use cases. Okay, so as I said, testing is very big area, and it covers there are so many types of testing. Of course, we are only covering the unit testing, but there is, as I said, integration testing, functional testing, end-to-end test. Regression testing, this is when you change something, when you make new improvements, or you change anything, you have to test again before you deploy it. Load testing to make sure that the system can handle the expected load. Let's say how many concurrent, you put on it 1,000 concurrent users and see if the system can still handle it and provide an acceptable response time. And so on. Usability testing is that the users can use the system to achieve the use cases without too much trouble. They can find the functionality, they can navigate, they can achieve their goals without kind of pulling their hair. It's very, very important, usability testing. So we are not, of course, touching on these. We mainly do unit testing and some level of integration testing. Okay, so unit testing, as I explained, is to verify that the smallest unit in your implementation really works and works as expected. Very important, works as expected. So the idea is that you take the function, you call it, you have some expected results, and you compare it with the actual results. If they match, that's a good news. Otherwise, you have to find what's the problem and fix it. So a good unit test should be isolated and independent. So each unit test should not test many things. It should test one and only one piece of code or one function. It should not test too many things in one unit test. It should be able to repeat it. You should be able to, whenever you make a change, you can repeat the testing. And that's the power of using some kind of automated testing. Because once you do some change, you can just rerun the tests whenever you wish. So it's repeatable. Which means sometimes if you are using, for example, a database, you can, before you run the test, you clear the whole database and you start again. So you can repeat your tests easily. And the results are always predictable. And when you run the test, when you feed some, you give some input to a function, the results coming back, it's not kind of random, or it depends. It is deterministic. So this will become clear as we go through more examples. So the unit tests are written by developers. Similar to the way you write code, you also write tests, unit test code, and then you push it to your repository like GitHub. So you can do it kind of on your own, write functions to test other functions, but it is common and highly recommended to use a testing framework. So depending on the language you are using, there are many testing frameworks. Like in Java, you have JUnit. In JavaScript, there are so many out there. Kind of chronological history. So started with QUnit, so people not so happy with it, or they find it limiting, they created Jasmine, and then from there they created Mocha. Like all these survived. So you have now many choices. So this Mocha unit testing is the kind of the most recent and quite widely used. That's the URL to get more information about it. So otherwise, if you don't use a unit testing framework, you can do that. You can write your own functions, but it's not very productive. It's not well structured. You cannot run it automatically whenever you wish. It's not as good as using a testing framework. That's all what this slide is trying to say to us. Okay, why unit testing? Very critical, very, very important to have it. Of course, it helps you to detect bugs early on, and you can improve the quality of your code. You can you can expose your high coupling. If your code is so much like spaghetti, it's very hard to test. Because if you really want to test your functionality, it has to be modular. It has to be, let's say, broken into function, and each function has one and only one responsibility. Then you can easily test it. If you try to test and it's not testable, means you have a big problem in terms of the organization of your solution and the design of your solution. So it will kind of pushes you and encourages you to even refactor and improve the organization of the code before you even test it, to make it testable. So if you want to make your code testable, you need to remove those tangling and those like unnecessary dependencies. Okay, now the unit tests, as I will show you and as you have seen some examples, could be a good way to have documentation. You know how developers love documentation? They all hate it, yes? So one way to kind of get them to document what is the expected input, what is the expected output, what is the correct expected behave, is to do that documentation in the unit tests. So it gives you a nice way of documenting your code. So once you invest, there is some investment, of course, up front. It will take you some effort to write those unit tests. But the good news is once you do that upfront investment, you can make reuse of it. Whenever you change something, first of all, when you have a unit test, you are encouraged to do changes. and to refactor and to improve, because you have confidence that you can rerun the test to make sure that you didn't break anything. Yeah? So by the way, in a critical environment, in real environment, you will be surprised. The organization will not allow you to release some code unless if you give evidence that everything has been retested. Okay. So how can you give evidence? So one way to give that evidence is you rerun your test and to give them all the green tick boxes. Everything is still working after my change. So because you can easily, when you change, you could break some other thing. So because you already have this unit test, you can rerun them. And you can basically change and refactor with confidence. So you're familiar with this term, refactoring? So what does it mean?
Especially in JavaScript, where we want to change like the name of an attribute, you just do refactoring and stuff. So
Okay.
changes for the whole document, not just for one.
Yes, that's an example of refactoring. For example, changing the variable names to more meaningful names. That's an example. But in general, what is refactoring? So basically changing the structure and the organization of the code without necessarily changing the behavior. So the functionality is exactly the same, like what I did for the maybe the model solution. Functionality is exactly the same. So you look at some submissions, you just run away. So complicated and so kind of unnecessary. There is a simpler way of doing it. So you can think of my model solution is just refactoring of some of the submissions. Same functionality, but a kind of a much, maybe more testable code, maybe more better organized, simpler implementation. So that's not what refactoring is. Changing the code structure without changing its functionality. So when you have this unit test, they encourage you to do this. But if you don't have this unit test, you will be discouraged because you will say, oh, it's working, why should I come near it and break it? So, but if you have unit test, you say, okay, I can take that adventure and I have with some confidence. It's all about confidence. And not confidence for you, you will always, as developers, we always take adventures. Why? Let's change this, let's make this better. But business people, they don't think that way. Business people, you have to give them evidence that you are not breaking other things by your changes. Yeah. And this is, by the way, called the regression testing. When you hear this, you see here the types. One of the types is called regression test. What is a regression test? Like basically making sure that changes that you have done did not break other code. Okay. All right. So as I said, there are many testing frameworks out there. One of them happens to be this Mocha framework. So in Mocha, what this Mocha allows us to do, it allows us to create what is known as test suites and test specs. So there are basically, typically for each JavaScript file, you have another JavaScript file to test it. Those set of tests included in one particular file, typically, it's called a test suite. So kind of a set of testing functions that are related. Let's say I have a book repository. I might have a book repository test suite that will test all the functionality provided by that repository. So typically it's a one-to-one. Most people organize it this way. So the way you create a test suite, you use the function describe. And I think you have seen this and you have played with it. Now if you you want to disable one of the tests, you can just put X in front of describe. Then when you run the tests, this test suite will not be executed. It's a nice way of disabling it, if you wish. Now the specs are the testing functions within the suite. So we create the suite using the describe function, and we create the testing units or the test cases using it. So I think it's best to just remind you how it looks like.
So doctor, this is for every repository and the it is for every function in the repository?
Yes, you can think of it that way. Although for each function you might have different testing. Because you need to test, I think here is the most important slide. Let me just jump to it and then I'll come back. This is very, very important. This is how really testing should be done. First, test one thing at a time. One focus per test. You don't try to test many things in one function. One thing at a time. And the function itself should be doing one thing. A function should not be doing many things. So you remember here, like this culture of unit testing will kind of force you to be modular. Because if your code is not modular, it's very, very hard to test. Second thing, you are testing the results, not the internals. Because the function or whatever you are testing is a black box for you. All you see is input and output. So this is important to keep in mind. And basically, you want to write positive tests and negative tests. For example, if you are testing a login, you need to at least have two cases. One where you provide a valid login credentials, and it says to you, yes, you are welcome to come in. And you provide the wrong ones, and it should say, no, you are not allowed to use this system. Yeah. So, because you might. If you don't do the second test, it might always allow everybody, even if the password is wrong, it allows. So what I mean is not one-to-one. It's not one function, I have one test. It's one-to-many. So one function might have multiple tests. So for negative tests, they involve values outside the acceptable range. So always you test the kind of the boundaries. That's where most of the errors happen. Let's say, for example, let's say I'm just testing a simple add function. So I'll give it different inputs. I give it, for example, 2 numbers, 2 small numbers, 2 medium numbers, 2 big numbers, and see if it still works. I give it a string and a number. So I'll give it basically a positive tests that I expect them to pass, and a negative ones that I expect them not to pass. So it's not one. The main thing to keep in mind is not one-to-one. It is one-to-many. And so for each function you have multiple cases. Some cases supposed to pass, and others supposed to fail. Yeah. So let me show you an example here. By the way, I have pushed this to GitHub just to give you an example of how you can test a repository. Because part of your project, you need to test at least the repositories. I have removed other testing, but repositories, you need to test them. So just to keep it simple, I'm creating here a test suite that will test the book repository. And as a convention, you see here's my repository. The test file is the same name as the file that I will be testing, with the prefix, with the suffix spec.js, and I put it under a test subfolder. Okay, so in here I will be describe means I am creating a test suite, and then within this test suite, I will be putting some functions to test the methods in the repository. So in the test suite, I can see if I have some functionality that must run before I start testing, I put it in this special function called before. So before I test any methods in the repository, I need to make sure I am already connected to the MongoDB database. Yeah, because these methods I have here, they assume that you are already connected. Yeah. Okay. So So that's why the preconditions that are assumed, I satisfy them, and I write the code to meet those preconditions in the before function. It's a special function that will be executed before the test cases will execute. And then there is an equivalent one called after. So this will be done before they run the test, and this one will be done after. So here I connect, and here I disconnect. If there is anything I need to run before each one, and after each test, I can put it in here. For example, I'm just thinking loud. You might consider deleting everything before every run. You delete whatever the previous. Let's say you have test cases, like 5 test cases, and before each test case, you clear the database and start again from scratch. Maybe. I mean, this one runs once, and these ones are run before and after each of the specs. Okay. Now, so if I wish, I can break down my suite into multiple blocks, it's just a way of organizing, in multiple kind of sub-suites. Or I can just put them all in one. So in here I have another kind of a sub suite of tests. These will be focused on testing the store. Remember, in this book repository, I am dealing with stores and books. Okay, so let me show you an example. In here, what I expect. So in the spec, I put what I expect. I say here, it means the function I'm testing. That's why they put it. The function I'm testing should do what? Should not create a store without a city. You see, that's why I told you unit testing can be used as a documentation. So if the developer disappeared, ran away, you can still kind of make sense of their code by coming to the unit testing, because the unit testing shows the intention of the function. So in here, remember the store has a name and a city, and both of them are required. Have a look at the model. Here's the store model. See, name is required and the city is required. So if you give just a name without the city, it should not allow creating a store. So that's what I'm trying to do here. Here is the spec. So, yep. Okay, so what I'm doing, I am here testing the negative case. So here I create a store just with the name without the city, and then I'll ask the repository, please go ahead and create this store. What I expect in this case? To be successful or to have an exception? Sorry?
It has to fail.
It has to fail, yes? So when I go to I expect that I will land in here, and I will get an exception. And what I expect this exception to be? I expect this exception to have a property called message, and this message should be store validation fail. If I don't have this, if I don't get this exception, this test case will fail. Yeah? Okay. Is clear what I'm doing here? Basically, look, testing is all about basically قُلْ هَاتُوا بُرْهَانَكُمْ إِن كُنْتُمْ صَادِقِينَ. That's it. This is what testing is. You must provide evidence that your code works. If you don't provide evidence, you cannot. Yes, we know, we kind of trust your word, but we need to see evidence. That's what unit testing is. And testing in general, that's what testing in general is. Okay? So here is an evidence. If I try to add a store without city, what I should expect? A failure, like an exception, and very precise exception, an exception with this message. Okay. Now this is a failed case. This is a good case, like a pass case. This is a negative case, and this is a pass case. And here I give the function all what's needed. I go ahead and say, please go ahead and and store and basically add the book, what is the evidence that this is successful? Can you think of some evidence?
Maybe like the URL that's added.
No, remember, this is a repository. It's not a web-based yet.
You can get the stores and then check if it's added or not.
Okay, very good. Yes. So for example, we're starting from an empty store. You see here, when I start the test, what I do to the whole database? Drop it. That's what I meant by repeatable test. If you don't drop, you cannot repeat this comfortably. I'm dropping everything. I'm basically starting from scratch. So, being the first store I'm creating, what is an evidence? What is a simple evidence that this works?
There is something in the database.
Sorry?
That the store exists.
The store exists, and how many stores we should have?
Only one.
One. If I get 2 or 3 or 0, it's a problem. See, that's exactly what I'm doing here. First, I expect that the store has a property underscore ID. Remember how MongoDB works? When you insert, did I provide here minus underscore ID? No. So if this one succeeds, how do I know?
Automatically it
has this. If it has this, خلاص. But I am not still, I want to give you more evidence. حجة دامغة, as they said. I want to give you more evidence. So as more evidence I put, the better. Okay? So in here I expect also the count to be 1. Is enough?
No.
If not, no problem. I can go to this store and expect that the name should be ABC store and the city should be Java. Any more evidence? I can go and query by this ID and check that the name is this one and the city is this one. Okay? But I think this is reasonable enough. Okay. So that's what I mean. Like the more evidence you have, the better. And you test for positive and negative. That's basically the idea of testing. So in here, what I'm doing. Okay, in here I'm testing the init DB. Remember we have a function called initializing. Here is a lousy testing, of course. I can be more critical or I can be more lenient. At least I do some testing, at least. But the more evidence I provide, the better. Okay, in here I'm doing initializing the database. After this, if this one is successful, I expect 5 books and 2 stores being created. And remember that init empties the database. So the test that I've done before is not a problem. It will be cleared. So, sorry. So that's basically the idea. You do some work and then you try to collect evidence that what you have done worked. That's basically the idea of unit testing. So if I get 5 books and 4 stores, I am happy. This will basically succeed. You get a tick for this. If I only get 1 store, then it's a problem. Or I get 5 stores, it's a problem. Okay, so here's another one. So here I finished with testing the stores. Within the same suites, I have broken it down into 2 sub-suites if you want. Just to keep things organized. I'll be testing the book. Here I'm querying the categories. I know there are 5 book categories. So I expect to have 4. So basically I get the categories and then say the length. What is the length? Yes, it is equal to 4, I'm happy. If it gave me more or less than 4, it's failed. Yeah.
What about if our function is retrieving whole objects? How to check it?
Yes, you can. Like for example, in here, I'm retrieving the book with the ISBN 234. Yes, I'm basically what I'm doing here. I'm checking if the title is Java 8, then I'm happy. When here evidence could be any. Your imagination is the limit, and how basically what's the level of confidence you want to establish. For me, if I retrieve the book with ISBN 12234, I expect the title is Java 8.
For a large database that we don't know in each entry of the database, we're not, like, I will never remember that.
Very, very good point. Very good point.
Java 8.
Very good point. Remember, tests are predictable. You know the input, you know the expected output. That's why everything, when you do testing, it's under a controlled environment. So even in science, when they do these scientific tests, it's under a very controlled environment. They know they have control over the input, they know what is the expected output. Okay? So that's why I never do this testing on a live database or something like that. I am dropping the whole database, starting from scratch. In the real world, you have a special environment for testing. So in the real world, you have development environment, testing environment, and a live environment, production environment. So when you finish with development, you move it to testing. When you finish with testing, you move it to production. So in here, I dropped everything. And I have my test. This is my test cases. I know them by heart. Okay, I know that 234 is Java 8. Is it?
Yes.
Yes. Yeah, I'm not testing a kind of in a dark. I know the input. I know what is the expected output. Yeah, that's what testing is. All you are trying to do is to establish evidence that what you're doing is working or not working. Is clear? Yeah. So you definitely you need to control the input. And that's why you have this, if you notice here very deeply, that's why this gives you this control. You establish what you expect before you start the testing. So for the testing to work, I expect the database is empty, clear. I start from scratch. And that's why I execute this code before I run. Of course, if I don't put this, all my tests will fail. Because it might have some other data from previous runs, or somebody is doing, or if I am testing, I never test in a live environment, or I test under a controlled environment. Okay, I think now you get the taste of what this is all about. So here, for example, I am querying by category fun. Yes, get books by category. And I expect them, how many books? 2. How do I know that they are 2? Because my input has 2.
Also, Dr. when you're developing a program, you're not really using the real databases, right?
You can, but usually when you're testing, you are testing on a small scale. Unless the goal of the testing is to do stress testing or load testing. That's a different type of test. So in here I'm doing functional testing. My goal is not to say, whether my program can handle like a database with million records. That's called stress testing or load testing or performance testing. In here what is my goal here? Is to verify that the functions work as expected. Which means I compare the actual with the expected. If they match, celebrate. Otherwise, you have to work harder to fix it.
Like we gave it like a mock database.
Yes, yeah, for sure, yes. But this is realistic. In real life, this is a good point. In a real life, what people do, they take some data from the live. Yes, only sample to do this, yes. So it is realistic, but sometimes they even anonymize it because sometimes maybe this is real information. You don't want to show it to developers or testers. Okay. All right. So I think hopefully you are getting the idea. All right. Okay. Last thing I want to show you. If I want to test the service, remember the service, you can test the service. That when you call a service, which is an API, you expect certain results. So there is a small plugin called Kai HTTP So you load this plugin, and then you use it to say to the testing framework, please go ahead and request this URL, get to this sub URL, and make a request. What you expect is the status is 200, that the body has an array, and basically the size of the array is 5. If I get this, I'm happy. Yeah? Because if you look here, when I do this API, here is the first book, second book, third, fourth, fifth. Okay? I can, of course, I can do further tests and say, oh, the second one, title of it should be Java 8. Or the last, evidence, it's a wide. You can provide different types of evidence. So as long as, just kind of, at least satisfy yourself. But if you have some team leader or some other more demanding, then they might not be satisfied with this. You might provide more evidence. Yeah? So it's all about evidence. Is this clear? Yeah. That's it. This is what testing is all about. So let me just see if I missed anything. Okay. So this is the test suite, and these are the specs. Now, the way you write these expectations, there are different styles. You don't need to worry about them. This is the style we are using. This is the most kind of more elegant style. You put expect, you put the actual, and you compare it with the expected. There are other styles. Assert this is equal to this. These are kind of more traditional style of writing unit tests. This is more recent way of doing it. It's just your own test. Whatever style you're comfortable with, you can use. We are using this style. Now for the assertions, you have what is known as matchers. So, for example, you have to be true, to not equal to throw, to have a property, to throw, and so on. So what I mean here, these matchers, there are, the most common ones are the ones listed here. You can go and have a look into more examples. These matchers allows you to compare the actual with the expected. Okay. Set up and tear down, I already explained this. You can have some code that runs before the whole test suite or after the whole test suite, or before and after each of the test specs. Good unit test, this I explained. So unit testing is a very, very important in any development process. So you can use, it's recommended to use a unit testing framework such as Mocha in our case. And in our case, the Mocha testing frameworks allow you to create test suites and test specs. And the good thing, or the guideline, the most important guidelines to make your code testable is to have a modular code. And basically try to have these functions independent. They just take some input, do some work, and return some output. Don't try to create unnecessary interdependencies between the functions. The more interdependencies you have between them, the harder it is to test. Okay.